Neutron multiplication factor, it's represented by letter K. See, in a fission process, in chain reaction, what happens is the number of neutrons keeps on multiplying in geometric proportion. If we take the ratio of number of neutrons that are generated in the present generation to the number of neutrons generated in the previous process, if that ratio is taken, what you will get is called neutron multiplication factor. You can say that the neutron multiplication factor K is defined as the number of neutrons in present generation divided by the number of neutrons in the previous generation. This ratio is known as neutron multiplication factor. The number of neutrons generated in the present generation and the number of neutrons produced in the previous generation, that is known as neutron multiplication factor. See, this value K, if it is less than 1, then the chain reaction may not sustain, it may die down after some time. Next, if K value is equal to 1, then the process will reach a critical stage. That is, the number of neutrons produced in the present and previous generation are exactly equal, so that the chain reaction will continue, and the energy is released in a fixed manner, that is, in a given time interval, the amount of energy released will remain constant. That kind of condition is used in a nuclear power plant to produce electric current. And if K value is greater than 1, then this is known as supercritical. In such state, the entire fissile material disintegrates at a faster pace and releasing an enormous amount of energy all of a sudden. That becomes an explosion. It becomes an atom bomb also. That is what neutron multiplication factor.